So let's take a look at some examples. We're going to take into account that our coefficients are real numbers, the a's, right? And our exponents can only be non-negative integers. Okay? All right. Okay, so here's what we're going to do with this. Yes, it is one. Okay, it matches the definition. Anybody choose B? Anybody choose B as an example? Is B a polynomial function? No. No, it is not. What kind of function is it? It's a rational. This is a rational. How do we know that? That x minus 1, right? This thing doesn't exist where? Where is our asymptote on this one? At 1. Very good. Okay, so this is no. How about C? Anybody choose C? No, you say it's no? Let's go back to when we looked at even and odd functions. Is 5 the same as 5 times x to the 0 power? Not the same thing? Yeah. So is this a polynomial function? Yes, it is. Right? Because anything to the 0 power equals what? 1. So, yes, 5 times x to the 0 power is essentially 5. Remember we talked about those constants being even when we looked at even and odds. How about D? How about D? Is D a polynomial?
No.
What are we going to get if we multiply that out? What are we going to get if we multiply that out? We're going to get a quadratic? We're going to get an x squared? Yeah. So this is a quadratic. So yes. How about E? Did anybody use this one? Yeah. This one, is it yes or no? No. What was your decision based on? That negative exponent. Exactly. And what about F? Yes. Yes. Okay. Can we have halves and negative 2/3 and fourths for our coefficient? Yes, we can, because we established that they could be real numbers, right? And fractions are real. Okay, very good. Any questions on those? So we just looked at our positive even integers, okay? We found that, in fact, they act exactly like a quadratic does. Okay. A quadratic is symmetric with respect to the y-axis, so are your evens. We have already looked at that. We looked at that about a month ago. Again, what did we find holding true? That domain was the set of all real numbers. However, the range, use your non-negative real numbers, right? So we'd say y is greater than or equal to 0. If you go to your table, and take a quick look, you'll see that all three of them contained these 3 points, negative 1, 1, 0, 0, and 1, 1. Okay? And you noticed that magnitude just kind of stretched as you increased on those values. So we essentially have something like this. Right? We have what we call our end behavior. That end behavior is what is happening at those arrows. What's happening as this thing is continuing on? Well, here, the domain is all reals, right? So for the domain here, that is headed out to negative infinity, and this one is headed out to positive infinity, right? Those are our domains. And what's happening with the range? As this is going to positive infinity, what's the range doing? Where's he going? He's also going to positive infinity. And then over here, as your x is going to positive infinity, what's your range doing? He's also going to positive infinity. Very, very important concept for you to understand, okay? Because when we go to graph these, you have to understand what that end behavior is doing, okay? Important for us, our odd function, it was symmetric with respect to the origin, and we had learned previously that it had also done that 180-degree rotation. Symmetric with that 180-degree rotation through that origin. Okay, again, is the domain the set of all real numbers? But did the range change this time? Range is different this time. Now the range is also the set of all real numbers. So let's take a look at that. Let me draw one up here. Let's look at our end behavior. Right? So they're doing this. So the domain. So let's look at our x. So as this is going to negative infinity, right? Or if we go this way, this thing's going to keep continuing to go out to negative infinity, right? So the domain is negative infinity down here, this end behavior. And then as your domain is headed this way toward positive infinity, right? But it's just going to continue, and you see how it just continued to gradually go out. So that end behavior is positive and negative infinity for your domain. Let's look at the range. So as your domain is going here to negative infinity, where is the range also going? Right here. The range is also going to negative infinity, right? What about up here? It's going to positive infinity, isn't it? It's going to positive infinity. So your range goes from negative infinity to positive infinity. That is different, right? Our evens, your range they were both going to the positive infinity. So this is your end behavior. Very, very important concept. We also had those same points, and then you kind of saw what was happening on number 4. You don't really need to copy that down. Any questions on that one? Okay. So we remember from quadratics, zeros are the x-intercepts because that's where y equals 0. And our factors are binomials, okay, that you're used to. And remember that the zeros, x-intercepts, are also the solutions to the equation. Okay, so we have a function, f of x. It is a degree 3, and we have 3 zeros. Now, remember how we got those zeros, guys, right? From our binomials, right? X minus r, or x plus r maybe, right? So if we have a 0 that's negative 4 inside our inside our binomial, we're going to have x what? Plus 4. Okay. If our 0 is negative 2 inside our binomial, it's x plus 2. And our last one, our third 0 here, the 3 inside the polynomial is what? Negative 3. Okay. How are we going to find that polynomial? What do we need to do now? Distribute. Could we take these first 2 right here and use FOIL? Yeah, let's do that first. So if we did that, we would have what? X squared. Take your outer and your inner. That would be 6x plus 8. And times the x minus 3. So now you're going to have to do what? Now you're going to have to distribute. So let's do that. Start with your x. X times your x squared. Go back again. X times the 6x. One more time. X times 8. We'll start all over again. Now we're going to do the negative 3. The negative 3 times the x squared. Okay, that negative 3x squared, I'm going to put below the 6x squared. Because I know I'll be able to add them up, right? Because they're like terms. So I'm just going to go ahead and put it right there. The negative 3 times the 6x. X, so I'm going to put him under the 8x. And then what's our last one? minus 24. Okay, so let's combine your like terms. So we have what? X cubed plus 3x squared minus 10x minus 24. So is this a polynomial of degree 3? Is our highest power 3?
Yes.
Yeah. Okay. So we could go to our graphing calculator to verify our result. We're just going to look to see what they have. One thing before I show it to you, they are going to show you that they had put the A on the outside, okay? Because sometimes we might have a greatest common factor that we have factored out of there. It could be a negative. If we had a negative out there, that would mean we had reflected it. Or let's say we had a number. Let's say I had the number 5. What would that do to it? What does your A do? That would have done what to it? Vertically stretched it? Or we maybe could have vertically compressed it. Okay? The A, however, will not change the roots or the solutions or the zeros. Okay? And let's take a look. Okay? So we have the roots -4, -2, and 3. So if we take a look at what we did not take into account that we had an A, or essentially the A was 1. Look at our graph. Here's our -4, here's our -2, so here's our -4, here's our -2, and here's our 3. Okay? Now, what if we put a negative out there? What if we reflected it? So you can see that we reflected it. This is down now. It went up like that. But did that change the roots? Did that change the solutions? No. And then over here, they did a 2. So basically, they just did a vertical stretch. That vertical stretch is still not going to change your roots of -4, -2, and 3. Okay? Any questions on that? So all this is really saying here is we're talking about the exponent. Okay? We're just talking about the exponent of the binomials. Okay? How many do we have? Okay? How many do we have? That's really all it is saying. All right, so our first zero is right here. What's our 0? X equals 2. Okay. We're going to say that 2 has a multiplicity of 1. What's the power to that? What's the power of that binomial? What's the power? 1. That's all it is. Okay? That's all it is. All right? Our next one, what's our 0 for the x plus 1? -1. So -1 has a multiplicity of what? And our last 0 here, what's our 0 there? 3 has a multiplicity of 4. Okay. This is important because it will show us here in a little bit. It'll show you the importance of it is where that 0, does it cross at that 0, or does it just touch and go back down, or touch and go back up? X-intercept. That's when y equals what? 0. Right? X-intercepts are when y equals 0. So if I have an x times an x minus 3, this thing's going to be 0 at where? Where this x equals 0 and where this x equals what? Where's your 0? 3. Okay? So that's our x-intercepts. We have 2 of them. All right, your y-intercepts. That occurs when x equals 0, right? So let's do that. So we're just going to replace all our x's with zeros. So f of 0 is going to be 0 times 0 minus 3 squared? What's that going to give us? If you have a negative 3 and square it, you get a 9. But when you multiply that by 0, what do we get? 0. So we get a 0. All right, so we have for our y-intercept 0, 0. And for our x-intercepts, we have 0, 0. Oh, double duty on that one, right? And then 0, 3. Okay. So let's take a look. Let me change color. Mm-hmm.
Why isn't it 3, 0?
Did I do it wrong? All right, so let's graph the y-intercept at 0, 0. Right there. And then that is also the same as one of our intercepts. And then our other 0 at 3, 0. So come on over here. 1, 2, 3. Okay. All right. Now, we have our intercepts. Now what we're going to do is, what is this thing doing? What is this thing doing? We really don't know. Okay? So what's happening? What's happening between 0 and 3? I don't know, but I can find out, right? What's happening at 1? What's happening at 1? Let's try it. What's happening at f of 1? That means I'm going to have 1 times 1 minus 3 squared, which would be what? 1 minus 3 is negative 2. Negative 2 squared is 4. So I know at 1, I'm going to be up here at 4. Okay. So we've got a little bit happening here. So we now know that we're going to go up here, and we're going to have to come back down because we know we have to hit that 0, right? Okay. So what's happening on the other side of our 0 here? What's happening at negative 1? Let's find that. What's happening at negative 1? So I'm going to have a negative 1 times the negative 1 minus 3 squared. I put it, no, okay. So negative 1, negative 3 is negative 4. Negative 4 squared is 16. 16 times negative 1, negative 16. All right, so at negative 1, we're way, way down here at negative 16. I don't have enough room. Okay, so let's connect. So that means we're doing this. We're coming up. Now, the last thing we need to decide is what's happening over here. Okay, so this is what, 3? So let's try 4. So let's try 4. So f of 4. 4 times 4 minus 3 squared. 4 minus 3 is 1. Stop. And 1 times 4 is 4. So 4 gives us what? 4. So we're back up here. So what happened here?
Goes back up.
So he goes back up. So he went back up. Okay.